Okay, as you can see, I've got a graph here on the board. And what I want to do is I want to find an equation of this type to try to come up with a formula whose graph would have this. Now, I've graphed just one period of this. The assumption is that it continues on forever and ever and ever. Okay. So I need to figure out what my A, B, C, and D are based on how I've transformed my basic graph of tangent. Okay. So let's see. I think I'm going to start with the horizontal stuff, which is this right here. Okay. Now, if I take a look, I can see that this graph starts at -1/2 and goes to 1/2. So the period is ending point minus starting point. 1/2 minus a -1/2 is 1. But I know that that period should be pi, which is the original period of tangent, divided by b. That's going to tell me what b is. Okay. So now I can say, okay, that means that b is equal to pi. Just multiply both sides by b to get it out of the denominator here, and that tells me what what b is, that it's equal to pi. Okay. Now, with that, then I can start looking at d. Did I shift things at all left or right? Now, I might be comfortable at this point saying, no, I did not, because I can see these asymptotes are evenly spaced around 0. So even though this point isn't at a height of 0, because I've done some stuff to this vertically, I can see that the asymptotes are evenly spaced around 0, so I haven't shifted anything left or right. If I wasn't confident about that, once I know b, I can actually figure out what d should be. Because I know that we're going to go through one period as b times x minus d varies between pi over 2 and negative pi over 2. Okay? But I know that b is pi. That's nice. Okay. So I can divide through by pi, which of course is just multiplying by a pi. That's fun to say. So I get -1/2 less than x minus d less than +1/2. And then I'd say, what does d have to be so that I start and end at -1/2? D would have to be equal to 0. Okay. Otherwise, what I would do is I would just say -1/2 plus d equals my starting point, but that's -1/2, so that tells me that d is 0. Similarly, -1/2 plus d has to equal my ending point, so d has to equal 0. Okay. So b is pi, and d is equal to 0. Excellent. So we've gotten what we can out of things horizontally. Let's take a look at the vertical stuff. Okay. So if I take a look, I know that tangent is usually going up. This graph is going down. That right there tells me that a had better be a negative number. Okay. And if I look at these points, okay, all of these points are gotten by taking my original y values and then multiplying by a and adding c, where of course if c is a negative number, then I would be essentially subtracting. Okay, so I want to try to figure this out. The easiest one is to start with the one that's exactly in the middle. And I should have mentioned this, because my board is smaller than what I have in the classroom, I didn't actually put up a graph of tangent to have as a reference. I would suggest, if you don't already have it in front of you, stop the video, just draw yourself a graph of tangent, a reference graph of tangent to have to be looking at as we're trying to figure out these transformations. Okay. So I know that the point that's halfway in between my asymptotes, usually that's at when x is 0, and that's at 0. Okay. Multiplying 0 by a won't change it, but adding something to it will. So if I start with the point that corresponds to when x is 0, what's halfway in between my asymptotes, if that's at 0, then I haven't transformed it, or I haven't shifted things up or down. But if it's not, I've moved things up. And I can see I've moved that up 1. So that tells me that C is equal to 1. Want to find that first, because this point, whose y value is 2, that's going to come from taking a point that would have been at a -1, because my basic graph of tangent would go asymptote, point at -1, point at 0, point at 1. So at -1, I would multiply -1 by A, and then I would add C, which is 1, to get this value of 2. Now that's going to allow me to solve for A. So that's saying -A is equal to 1, A is simply equal to -1. Okay. Let's just make sure that works. Okay. We said ordinarily we go -1, 0, 1. If I take this point, which was at 1, if I multiply it by -1, it becomes -1. Plus 1 is 0. That is the new y value here. So I'm able to say that this is y is equal to 1 minus tangent of b, we said was pi, and then just times x, because we said that d was equal to 0. We hadn't actually shifted this to the left or to the right. Okay, kind of fun. Now what I'm going to do is I'm going to keep the graph the same, but I'm going to change the question very slightly. I'm going to say I want to get this as a transformation of the cotangent graph instead. Same graph, we're going to get a different equation that gives us the exact same graph. It's just going to be a transformation of cotangent. So if you don't have a reference graph of cotangent in front of you, make sure, write one down, pause the video, get yourself a reference graph of cotangent, because I don't have a lot of room on the board to draw that, but I want to be able to refer back to that. You know what, actually, I probably could fit one in here. I lied, I've got enough room. So cotangent looks something like this. This point is at pi over 2. This would be pi over 4 comma 1. And this would be 3 pi over 4 comma -1. Okay, so I want to get this as a transformation of that. Notice, this is now going down the same way as cotangent did. So now I know that my A is positive this time. Okay. Again, let's do our horizontal transformations first. Okay. The period is still just 1. So if the period is 1, and that's the old period over B, that's going to mean that B is equal to pi. Okay. So that part hasn't changed. Okay. But D will have, because my basic cotangent graph has an asymptote at 0, and it looks to me like we've shifted things a little bit to the left. Okay. In fact, we've shifted that asymptote 1/2 to the left. Okay. So I'm going to say that D is equal to negative, because we're going to the left, 1/2. Notice that way x minus D will become x plus 1/2. And remember, when we add a positive number, that shifts things to the left. The horizontal transformations are counterintuitive. Okay. So by finding the period first, then I can find the horizontal shift. That's kind of nice. Okay. And then I want to find my A and my C. Okay. Again, I'm going to actually find the C first. I'm going to look at this middle point, which corresponded to this middle point, okay, where the y value is 0. So that it's not affected by multiplying by A, but I can see we've moved it up to 1. So once again, C is going to equal 1. Okay. And then what's A? Well, it's a positive number. Okay. And if I take a look, this point right here would have corresponded to this point right here. So I would have taken the y value for this point, which is 1. I would have multiplied it by A, added C to it, and I need to get the new y value of that point. So the old y value times A plus C gives me the new y value. But then this just tells me, since C is 1, I get A plus 1 equals 2, A is equal to 1. So this graph is y equals, C is 1, plus A is just 1, so I'm really not scaling this graph at all, plus cotangent of pi times x minus my d, so x minus a negative 1/2 is x plus 1/2. All right, some fun puzzle solving there. That finishes up for us section 4.3, which is on the graphs of tangent and cotangent.